Good morning. My name is Dr. Gold. We're here today to demonstrate the functional utility and the power of the Sonostar dual-headed color Doppler ultrasound probe. This is a full ultrasound system contained in a single unit. We have both a curvilinear probe on one end and a linear probe on the other end. So what we're going to do today is demonstrate how to do an ultrasound study and the basic functions of our app. This has a built-in Wi-Fi transmitter. This is how the system connects with the viewing screen. This is not Bluetooth. This does not rely on any outside networks. It's its own Wi-Fi transmitter, 5G Wi-Fi transmitter. For you folks interested in the technology, it's referred to as a MAC protocol, very cyber secure. So what we're going to do first is, as if this were straight out of the box, we're going to power the unit on. We're going to connect it to our viewing device, and then we'll begin the basics of how to use all of the controls on our app. The functions are controlled by a downloadable app, free software, always upgradable, very powerful utility. So right out of the box, the first thing we do is apply pressure to the button here in the middle of the probe, and that powers the probe on, indicated by the blue light, and in the battery window. The presence of the blue light on either end indicates which end of the probe we're using. Right now we're connected to the curvilinear side. For today's demonstration purposes, we're going to keep this very straightforward and do a superficial exam of the neck. So I'm going to come back to the linear side of the probe, and to do that, I depress the middle button for a few seconds, and the blue light will switch to the other end, indicating that now the linear end is active. At this point, we're ready now to connect the probe to the viewing device. We simply have our device ready to go. We will go to our settings. It needs to be turned on. My assistant, Dr. Garcia, will get us plugged in. We're going to go to the settings. And the first thing we look for is the fact that our Wi-Fi system needs to be activated. We'll turn that on, and at that point, the signal from the probe will be recognized by the device, and here we see the indicator that this is already connected to the viewing device. If it were not, it would be displayed here in the list of available Wi-Fi selections. We would simply pick that as our selection. Here it is now, because we've changed networks. I go back to that. This is indicated here. The password is located at the bottom of each probe, so you never have to remember it. This one ends in 017, so we've identified that this is 017, and we are now connected to this device's Wi-Fi network. At this point, we go back to our viewing screen because now we're connected, and the next thing we do is open up the app. And what you can see here is a standard viewing screen for an ultrasound signal. Each time the screen opens at the very beginning, it's in the freeze mode or still mode. This is because we are at the very beginning ready to enter patient information. So at the beginning of each exam, we put in our patient demographics on this screen, easily accessible by the button here. Once the patient demographics are entered, and something to note is that the birthday itself requires individual scrolling of each unit in the date, up or down. Once the demographics are entered, touching anywhere on the screen will leave that, and up here in the upper right-hand corner, all of the patient information will be displayed, the patient ID, name, gender, and age. At that point, we're ready to begin scanning. One of two ways activates the probe out of the freeze mode. Either touching the freeze button here in the lower left corner of the screen, and now we can see the word live in the viewing screen indicating we're ready to begin scanning. The other way to do it is by touching the button on the middle of the probe in a snapshot fashion. A single touch of the button takes us live, and now we're ready to scan as well. So at that point, we are ready to begin demonstrating the functions of the probe, how to acquire an image, and how to adjust the image. So we'll get our patient ready, and we'll begin scanning with an explanation of all the functions. All right, so at this point we have our patient ready. We're going to put the probe on the patient's left side of his neck. We're going to see what we can see as far as his carotid goes, and in so doing, we will be able to demonstrate all of the functions and controls of the ultrasound viewing screen. For orientation purposes, each probe has one small mark on the lateral edge of each of the heads. This small mark indicates whether you want to be lateral or medial, depending on the orientation of the examiner. That corresponds to a very small green dot on the viewing screen as a way to orient the image to the provider. So at this point, I personally always put the orientation mark lateral to the patient. So we're going to lay this on his neck, and I'm going to need some more gel. Quinn, if we have any more gel. I put a tiny little bit on here. Let's see. And this is a good place to start because at this point the image is dark. So we're going to improve this image, but you may not be able to appreciate it at this moment, but the carotid artery is in the middle of the screen. So the first thing to do is notice the first control is referred to as gain. That simply brightens the image or darkens the image. The parameters are displayed in the upper left-hand corner of the viewing screen, and here we're monitoring the changes that occur to the number next to the letters GN for gain. Right now we're at a very low number of decibels for the gain. It's at 32. Dr. Garcia will be increasing the gain all the way up to its maximum, which I believe on this machine is 105. So now we're increasing. We should see the image brighten up as we go from the 30s all the way up towards 100. Yeah, it's going. No, it's fine. Just you can touch the button and hold on to it, and it will continue there. And you can see it brighten as we go. And now we're approaching 100, and then we'll stop at the upper limit. Keep going. It'll go further. Touch it again. And there is the maximum in the gain at 105 decibels. You could appreciate that the image became significantly brighter during that time. At this point, with close view of the image, you're able to see the carotid artery pulsate. If the patient were to strain or cough, can you give me a cough? Okay, go ahead. Perfect. So the structure adjacent to the carotid is the internal jugular vein, and when you increase intra-abdominal pressure or intrathoracic pressure, that vein dilates from intravascular pressures. What we'll do next is demonstrate what the image does as we decrease the gain. And we'll go all the way back down to where we were at the beginning of the exam. If you just touch it and hold it, it will go all the way down on its own. You can appreciate that the image is darkening. We are going all the way down. Keep going, that's great. So you can see there's quite a range of variability from the 30s up to 100. So at this point we're going to go back up to the middle, somewhere around 70 to 80. Well, let's go up to around 80 on the gain, and we'll do our exam, the rest of our exam at that point. There's a little bit of lag. That's good there. We'll examine at that point. We'll demonstrate other ways to change the image quality, darker, lighter, more focused. At this point, I'm going to take just a little bit of gel, and this always helps. Make sure you always have enough of this ultrasound gel for the exam. It enhances image quality tremendously. I'm going to replace the probe now. And again, that's the carotid artery in the middle of the screen. Let's see what I can do to get the best view. Now, the next control down on the app is what is referred to as depth. Scanning depth is adjusted from very superficial to deeper. The linear probe on this device will scan from 20 millimeters up to 80 millimeters, or in other words, 2 centimeters to 8 centimeters. At this time, you can see on the screen the value listed next to the letter D is 40 millimeters. So there are two ways to adjust the depth. One is to actually move your finger on the screen, and we just went from 40 to 20 millimeters, and as we scroll the other way, we can go all the way to 80 millimeters in depth. The other way is with the button. Dr. Garcia will be able to touch the depth button on the app, and we will cycle through the depths of probing. And there we are back to 20. Let's go, well, we skipped one. That's actually good. We're going to stay at 4 centimeters or 40 millimeters for demonstration purposes. The next control down is referred to as focus. The arrows on the far left of the viewing screen indicate where the linear ultrasonic beams that are emitted from the probe are come together the closest in energy, and highlighting then in a focal point something similar to the rays of light that get bent on your lens of the eye to focus them into a point. This is the place on the viewing screen where the ultrasonic signal is best focused in intensity. That's controlled by the button labeled focus. If you watch closely, the arrows on the left side of the screen will change their position from superficial to deep, and the ultrasonographer or provider will choose the best location for those arrows based on the target of the image. The next button down is referred to as, is labeled DYN. That stands for dynamic range. As we adjust dynamic range, if the gain is considered to be the contrast of the picture, dynamic range is considered to be the brightness. Dr. Garcia will cycle. The letters DR on the screen at this point have the number 70. This is a ratio in the world of ultrasonic signals, so there are no units, and it will cycle from 40 up to 110. Now, Dr. Garcia demonstrated something. We're going to go back. Cycle through again, Doctor. Go to 70, 80. Just do it one at a time, and we'll get to a one. Now, stop. No, you went. It's okay. I want to demonstrate at 40 how bright and speckled the image is. The contrast is too high. The brightness is too high. Unless you're looking at something very small and you want to highlight that particular area. So that's the point in the exam where you'd want to achieve a much lower dynamic range. Now, this is the lower end. This is at 50, and you can see very clearly that the image is quite bright and pretty heavily speckled. It looks like someone put pepper on our screen. So we're going to move that up now just a little bit at a time from 50. And we'll watch the image change. That's good there, I think. So at that point, our image has become a little softer. We're able to see the structures a little more clearly without the bright reflectance. The next button down is labeled harmonic, but this is where we control the frequency. On this device, the two frequencies that the linear probe scans is 7.5 and 10 megahertz. That's demonstrated or labeled next to the letter F. In the area of the parameters, right now we're scanning at 10 megahertz. Once Dr. Garcia hits the harmonic button, it will change to 7.5, and the image quality, no, that's denoise, the next one up there. And that changes the image quality a little bit, and we should probably be scanning at 7.5 for this exam. The basic physics of ultrasound dictates that the higher the frequency, the lower the penetration. So if you want to scan something very superficial, you'd want to be scanning it at the higher frequency. We've dropped down now a little bit to 7.5, and this is a better frequency to scan at 4 centimeters into the tissue. The next button down is controls what ultrasonographers refer to as speckle. It's a simple filter for clutter in the returning echo. In this device, the denoise function is labeled ENH and ranges from 0 to 4. At this point in time on the viewing screen, we're at the number 3. So Dr. Garcia will hit denoise a couple of times, and we'll see it cycle up to 4. Okay. And then back to 0. Yeah, denoise. And then you can see this now is full of artifact and noise in the returning echoes. As we increase our filtering just a little bit, the image softens. Up one more. A typical value for scanning is somewhere in the middle of that range, around the level 2 for filtering. Based on your needs and the target, you can adjust the filter and eliminate more or less clutter out of the echoes. The next button down is very important. This is where we'll spend a little bit of time. This is referred to as the scan mode. At this time, we're scanning in the B mode. This is the basic black and white grayscale that we're all familiar with. And that's where you're going to do probably 90 to 95% of all your exams. Once we touch that button one time, we open up a menu, the B. There we go. And now we display the other scanning functions of the probe. This probe is very powerful in that it contains many of the color analysis functions used in vascular studies. These are in order: M mode, color Doppler, power Doppler, imaging, and pulse wave. The simplest demonstration to give is with the color Doppler. We have then a square that appears, a window on the screen. We can move this screen, the square, with our fingertip to get over the target, and there we see the color flow through the patient's carotid. Once we choose a function, more buttons open along the bottom for control of that function. So these are all of the necessary controls for color Doppler analysis. We won't go into the physics of each one today. Steer simply changes the angle of incidence. The gain is just what it says, the brightness of the Doppler signal. There are instructions on how high or how low to take the gain. We'll review that in another instructional video. Pulse repetition frequency, window, and then how to actually move or size the window screen. We can in fact make that a little smaller or a little bit bigger with our fingertips with this control, and then we can move the screen. But that's a great view of the color flow through the patient's carotid artery. That's a simple demonstration. Let me see what I can do to show you just a little bit of the incredible power of this function. This is a pulse wave Doppler. I'm going to try to center this over the patient's carotid. Now this, all ultrasonographers out there are cringing. This is not the exact way to do this exam, but what I want to demonstrate is on the window at the bottom, a regular pulse that we've obtained for the patient. Along the side of the window is a scale. This is a velocity scale. Simple functions would be to lower the baseline, and now we see more of the true form of the patient's pulse wave. Very classic arterial pulse waveform. The window and the angle of incidence can be changed here, as anyone knows, with the volume. The size of the window is adjusted. The angle inside the window and between 40 and 60 is optimal. We all know that. And then again, steering is the angle of incidence of the green line. I think you could appreciate that I changed that a little bit. And a perpendicular ultrasonic signal to blood flow, it's unable to measure any velocity. So everybody knows, and you do too now, to change the angle of incidence a little bit to help enhance the detection of echoes from moving. Actually, it's the red blood cells in the artery. That's a very powerful function that many of the other devices on the market right now do not possess. Power Doppler simply augments the signal from the regular color flow in case you're ever imaging in a low flow area and are uncertain of any flow. This will enhance that signal. And M mode, of course, is for cardiac primarily. If I can center this a little bit, you see the open area. This was closed before, now it's open. And if this were a cardiac exam, we'd be able to demonstrate outflow tracts and inflow tracts. That's our M mode. So I'm going to return now to the basic B mode, but very few handheld wireless probes. As a matter of fact, none of them on the market today will provide that kind of vascular analysis. At that point, we only have one more function to demonstrate, a button here referred to as biopsy. This is to enhance needle movement through the tissue to help you locate your target, whether it's a biopsy or vascular access, and we're able to control in plane, out of plane. The word clear simply takes the image off the screen. I'll demonstrate that, and then we're able to actually change our image orientation based on where the provider is standing at the time the needle is placed. I'm able to flip the image from superior to inferior and back, or I'm able to flip it left to right and back. Once I decide where my needle is going to go, let's say I want to do an in-plane biopsy or a needle placement, there is a dotted green line that appears on the viewing screen which will guide your needle. And to move this line, let's say for any reason that we could think of, we want to put a needle here. With the virtual trackball, I'm able to change the position of that line and get it directed over my target, up or down, left or right. Now we can see the dotted green line transecting the target, and that would help guide our needle in the direction and location we want it to. Now that's an in-plane needle placement, and out of plane is a simple vertical, because the needle now is exactly perpendicular to the head of the probe. I have a window here that you may or may not be able to see. Let me get the depth correct. I want to try to locate that over the target. But anyway, I also have a virtual trackball where I can move the target. I hope you're able to appreciate that. There's a small circle in the middle of the screen with the perpendicular line guiding it. And now I'm ready to try to put my needle in the middle of my guide, and I should be able to puncture my target. This moves the guide up, down, left, right, and makes the size of the guide larger or smaller. I don't know if you can appreciate that, but that opens up the guide circle further and decreases the size. Once I have that and I've got the image and I'm done with that, I can hit clear and everything goes off the screen at this point. I'm back to my regular B mode scan. Two more functions that you should know about before we finish up explaining about the basic functions. Many of the larger cart systems have a series of sliders on the console, which is referred to as time gain compensation. So one would think, well, you can't do everything that the cart can do, but in fact we can almost do everything that the big carts can do. We have time gain compensation sliders here hidden on the app. There's a small arrow on the side of the screen. Once we touch that arrow, the sliders come. And what this does is control the gain, again, brightness, controls it in the near field or far field. So if I want to control the brightness in the near field, I use these sliders. And I can make the image brighter here, or I can make the image darker in the far field, and vice versa, if we use the sliders. So that makes the top part brighter, the bottom part darker, and of course they can be reversed the other way as well. But this is referred to as time gain compensation. The physics are very basic about how far the ultrasonic signal has to travel before it returns to the probe. Touching anywhere on the screen takes the sliders off. The last point I want to make is up here at the very top is the word vascular right now. If we touch that word, we get a drop-down menu. This demonstrates some factory presets for the type of exam we want to be doing. Otherwise today, if we were doing a true carotid for velocity, plaque, everything else, we might have chosen the carotid preset. Otherwise, we're free to decide what kind of exam we want to do. What that does is alter the parameters, the basic scanning parameters that we went through on the left side of the app into a preset configuration, able to guide your image quality for that exam. It is a factory preset. So at this moment, the provider cannot pre-program their own presets, but in future updates of the software, I anticipate that we'll be able to set our own presets. I'm an anesthesiologist and I enjoy creating my own environment for my ultrasound images, so that option is coming very soon. But in the meantime, it's a very good set of parameters to guide you. Once you set what exam you want, you're still able to control them to fine-tune. So at that point, that is the final part of explaining the probe, the connection to the viewing device, the acquisition of the image, and control of the image quality. I'm going to move now to the final part of what this probe does and what the app does. When I have acquired the image that I want, whether it's with the needle in place, whether it's demonstrating a certain finding, or in any other way, something that I want to save, I simply either hit the freeze button on the viewing screen or the power button on the device, and I'm able to then freeze the image. Now this image is stored at this moment as a digital image, and I can perform certain manipulations on the image. First of all, we have always going on in the background, in the bottom left corner, a series of frames that are put together into what we call a cine loop, or a short video. This at this point is set for 100 frames in a cine loop. If we want to replay our cine loop, we simply hit the play button, and that gives us the previous 100 frames that were on the screen prior to the acquisition of the frozen image, or the snapshot. We can also now go to a very powerful function here referred to as measurements. This pop-up menu reveals a number of ways to take a closer look at the image we've acquired. On this, we're able to measure length, angle, area or circumference, or actually make a trace in case this were something irregular that we weren't sure about what it was, but we needed to know how big and we wanted to document that. For the sake of demonstration, we'll use length. At this point, my fingertip becomes the initial pointer. We've just applied a small green star onto the screen, and we want to go directly across from that, and want to know how wide that carotid artery is at that point. We now have a value here of 9.72 millimeters. This is a very powerful part of the application that many of the other handheld wireless devices do not have. This is a single measurement. We go back. I'm going to, at this point, use this button to clear that measurement. And now I'm going to do an angle measurement. Sorry, it didn't clear. And in that point, my fingertip becomes the pointer again, but I need to apply 3 different points to create an angle. At that time, the angle measurement is displayed here on the right-hand side of the screen, and the angle is displayed on the viewing screen. I can, in fact, then move the angle to create whatever I want to measure on my screen. Fully programmable with your fingertip, or you can use the trackball to move it left, right, up, or down. And that's a great way to know what's going on, perhaps in a joint area or any kind of fetal measurements. The next one is area or circumference. Again, my fingertip becomes the pointers. Then as I apply my fingertip between the 2 points, I open up a circle, and which then would become an ellipse based on simple geometry of the original diameter. And then I have displayed here the area and the circumference of that measurement. This is obviously very good for fetal measurements if you want to do biparietal diameters, etc. I'm going to clear that measurement. I'm going to do the last one, trace. So I have an irregular form. My finger again is the pointer, but I'm able to outline that irregular shape and still get an area measurement. So I can at least identify whatever unknown structure it is in terms of its size. I can apply all 4 measurements to one image if I so desire. And at the time that I'm finished measuring, I can now open up a screen with this button labeled Annote, A-N-N-O-T-E. At first, nothing happens, but all I have to do is touch the screen, and I should have a keyboard appear. It's down here, I guess. And I'm able to, I think this, there we go, I'm sorry. On many viewing devices, this will become a keyboard. And I'm not sure how to, we'll have to. Otherwise, we're able to create a note in the screen, which it appeared here. And then at that point, I'm ready to say I have the measurement, I have the image, I have the value for the measurement, and I have my note written on the screen. Left carotid, mid-neck, irregular mass, whatever kind of note you want to make. At this point, I'm now ready to save the image in a single frame, or I can save the cine loop on the viewing device. If I hit the word save, I get a message that I was successful with my save, and now that's stored on the viewing device as a digital file. The individual images are stored as DICOM files, and the cine loops are saved as a .mov file or movie file. I'm going to clear that off, I'm going to restore the other options on the frozen image. The very last function to demonstrate is the preset button. Ordinarily, we think of presets as the examination presets for the parameters, but in this case, it's a small screen that gives us three other options. If for any reason the white lettering, patient ID, or parameters were problematic in the viewing screen, if we toggle that show information off, the white lettering disappears from the screen. Toggle it back on and the parameters and patient information reappears. Cine loop is simply a way to go up from 100 frames. This will go all the way up to 1,000 frames, which is approximately a 100-second video. Approximately 10 frames per second. We keep it down for demonstration purposes. The last part is a series of options for channels on the Wi-Fi network. This can be used in very rare situations, but also a very important function in terms of competing Wi-Fi signals in your environment. If there's too much of a time lag in acquiring the image, one thing that might be done is to adjust the channel. The probe connects by default to its best channel. That's in pink. That's the default connection. So again, under rare but very important circumstances, we're able to adjust our connection from our own network to compensate for the other signal environment. When all those are set, we're closed, and that is the fundamental way to use our probe, acquire an image, manipulate the image, and ultimately then save the image for use at a later time after the examination.
Now a question here. Now how a technician comes in, does that, we get an image, how do we send it to the radiologist?
We have once the image is saved, we go to wherever you save the images here, photos. We select the image we want, and here on this particular viewing device, we have our choice of using the digital file any way we want to use it. So this is a DICOM digital file, and we can manipulate that file in the same way that we can use any other digital file. So that's how we've saved and now can transport that image. The best way to do this is with an app that's coming out very soon from our company, where all of the images can be transported directly to a PAC system. But that creation is imminent, and we'll have it very soon.